In the 2010 higher level paper, we can see that for question 1, the titration question, we are given the titration to find the total hardness in a water sample. So it's the EDTA titration. To get these calculations done, the first thing we're going to do is identify which values belong to which chemical. So what we're first going to notice is that our calcium ions, magnesium ions are represented by M2 plus in the equation. And then we have, it was found that 50 ml samples of the hard water, so that's the water containing the calcium and magnesium ions, so that 50 ml belongs to that M2 plus, the hard water sample. So those samples of the hard water before ion exchange required on average 9.2 ml of a 0.1 molar EDTA solution. So that's 9.2 ml of a 0.1 molar EDTA solution. And we can see that our EDTA is represented by this in the balanced equation. So that's before ion exchange, and then we're told that after ion exchange 50 ml samples of the water required an average of 2.4 ml of the same EDTA. So this also belongs to EDTA, and that 50 belongs to the water sample. So what we're going to get asked to do is to calculate the total hardness of the water before ion exchange in moles per litre of calcium and magnesium. So that M2 plus. I need moles per litre of the M2 plus. So to begin, I always write down the concentration that I know. So the concentration I know is 0.01 moles per litre of EDTA. So I have 0.01 moles per litre of EDTA. But did I use a litre of EDTA? No, I didn't. Before ion exchange, we used 9.2 mils of it. So to find how many moles are in 9.2 mils, I'm going to divide by 1000 and multiply by 9.2. That gives me 9.2 times 10 to the minus 5 moles in 9.2 mils of EDTA. So that's how many moles of EDTA were used in the titration. I need to find out how many moles of 2 plus ions that would react with. So we're going to have a look at the balanced equation and work out a ratio. So I want a ratio between EDTA and my M2 plus. So those are my calcium and magnesium ions. And from the balanced equation, we can see that it's a 1:1 ratio. So it's 1:1. So if I had 9.2 by 10 to the minus 5 moles of EDTA, that must have reacted with 9.2 by 10 to the minus 5 moles of my calcium and magnesium ions. So I had 9.2 by 10 to the minus 5 moles per. Now how much of that sample did I use? So of the M2 plus there in yellow, I used 50 mils of that solution. So that's moles per 50 mils of my hard water. It asked for moles per litre. So to turn that into moles per litre, I'm going to divide by 50 and multiply by 1000. And that gives me 1.84 by 10 to the minus 3 moles per litre of M2 plus. So that is part 1 finished there. Now what I need to do is calculate the total hardness before ion exchange in grams per litre of calcium carbonate. So I have moles per litre. I need to turn that into grams per litre. So I need to multiply by the molecular mass of calcium carbonate. And what we find is that calcium carbonate has a molecular mass of 100, because we have 40 for the mass of calcium, 12 for the mass of carbon, and 3/16 for the oxygens. That gives us 100. So I take my 1.84 by 10 to the minus 3 moles, and I'm going to multiply that by 100. And that gives 0.184 grams per litre of calcium carbonate. So that's part 2 done. Part 3 then asks for parts per million in terms of calcium carbonate. So we know that parts per million means milligrams per litre, and that's the same as grams per litre times 1,000. But I have my grams per litre from above, so I'm just going to take that value and multiply it by 1,000, and it will give me parts per million. So 184 parts per million calcium carbonate. And that's that finished. Then what we're asked to do is to repeat the calculations for the water after ion exchange. So I have to do all of these calculations again after it's passed through the de'ionizer. So what we need to do is find what values have changed. So we're told back up here that 50 ml samples of the water after ion exchange required 2.4 mils of the EDTA solution. So all that's going to change in these next calculations is the 9.2 here of EDTA we used last time is going to become a 2.4. Otherwise, everything else comes out exactly the same. So I'm just going to do the same sums I did last time. So I had a 0.01 divided by 1,000 times 9.2 last time. That 9.2 is now going to become a 2.4. So it will just be 2.4 by 10 to the minus 5 moles in 2.4 mils of EDTA. It's the same 1:1 reaction, and it's still in 50 mils of solution from this step, so I'm just going to copy this step using the number I have up above here. So I'm going to have 2.4 by 10 to the minus 5 divided by 50 times 1,000 to bring it to moles per litre again. So 2.4 by 10 to the minus 5 divided by 50 times 1,000. And that gives 4.8 times 10 to the minus 4 moles per litre of M2 plus. So that's part 1 done after ion exchange. Part 2 then, all that has me do is multiply that value by 100. So I'm going to take 4.8 by 10 to the minus 4 and multiply it by 100. And that gives 0.048 grams per litre of calcium carbonate. Sorry, pen's acting up. And then part 3 wants parts per million, and all I have to do is take my previous value and multiply it by 1,000. So 0.048 times 1,000 is 48 parts per million calcium carbonate, and that is those calculations redone out after ion exchange. Now I've gone through those second set of calculations very quickly, just looking at the steps I did from before. You could take your time with them and go through it methodically like we did first time around, and you'll still get the same answers. It will still work out exactly the same. It's just because we've already done them once, I just quickened it up for the second time round.